I'm Alexander, CEO of Beam. Beam is a scalable confidential cryptocurrency, which I'll tell you about, and we're based on the protocol called Mimblewimble. How many of you have heard about Mimblewimble before? Wow, everyone, almost everyone. That's so cool. Okay, so I'll start with a bold statement. So we have a lot of cryptocurrencies today. Are they fit for usage in business? And I claim that they aren't. They are not fit for purpose. And why is that? Because if you think of it, every business and also every private person needs confidentiality, needs privacy for anything that's related to finances, right? No one here, I'm sure, would agree to print their bank statement online on Facebook for everyone to review, right? And it's not because anyone is doing anything criminal, just because, right? We don't like sharing our financial with people. Now, and think of a business. If all my competitors see how much I'm paying my employees, how much I'm paying my suppliers, how much I'm earning, my business is probably ruined, right? Because they will poach my employees, they will pay more to my suppliers, they will charge less from the customer, and so on and so forth. So money loves confidentiality or secrecy, okay? But that's not the only thing, right? Money needs confidentiality, money needs scalability, right? That's very clear. And money also needs compliance, right? So about like several years ago, people who built Monero and then Zcash understood that privacy is important, and they built really great technologies that are based on the same Bitcoin architecture and add a lot of privacy stuff on top of that. It's brilliant stuff, but the result is that the blockchain is less scalable. But the existing cryptocurrency that are confidential, they don't provide any way to pass compliance, right? So if I'm a business and I wanted to accept Monero, I mean, that would solve the privacy problem. But then if I wanted to file a report to an auditor, or if I wanted to, go to a bank and prove them that my funds originated from the right place and pass AML, I couldn't do that. So our end game goal at Beam is to solve this. And in this talk, I'll actually walk you through what we're doing and how we are reaching that goal. So what is Beam, right? There are a lot of cryptocurrencies. So Beam is a new cryptocurrency that is, has a lot of very classical properties. It's proof of work consensus, fully decentralized, permissionless, deflationary, meaning we have a capped supply of coins. Beam is not a fork of anything. We started implementation in March last year by looking at the Mimblewimble protocol and just implementing it from scratch in C++. You may have heard about another implementation called Grin that started before us. So we started much later, but we launched on January 3. Right now it's a fully operational running blockchain. So this is our supply curve, right? So we have a capped supply of 262.8 million Beam coins. Right now there are 18 million in circulation with about 144,000 Beam emitted per day. Our first halving will be in January, in this coming January, so in about half a year. So right now the block reward is, for every block, 100 coins are emitted. In January it will be 50. Now, our financial model is based on what's called a treasury. Okay, it's somewhat similar to Zcash model. We haven't done an ICO or anything like that. We're against ICOs in principle. But the funding model we work with is based on this treasury. So what happens is that today, every minute, there is a block that's being mined, and the miner gets 80 coins, and another 20 coins are emitted into the treasury. And that happens in the first 5 years of operation. So this treasury is divided between our investors, who actually funded the development, the core team, and a nonprofit foundation that we're now setting up. And I'll talk about it a little bit. So what we have achieved so far, okay? We actually, I think we gained a reputation in the industry of a project that can move really fast. So, so far we have wallets for all the platforms, very easy to use, nice, beautiful, graphical wallets that actually hide all the complexity of the Mimblewimble protocol from the user. You just send, receive money, transactions are confirmed. So really best of breed wallets. The blockchain is obviously live. It processes about 4,000 transactions per day. We just crossed 650,000 transactions altogether. Hundreds of thousands of GPUs are mining Beam today all over the globe, mostly in China. We just released integration with a payment processor called Coin Payments. So now I actually made my first physical good purchase with Beam online, and more stores will join. We're trading on exchanges, so we've achieved a lot. Okay, sorry, I think I messed up this thing here a little bit. 1 second. Oh, okay, that's how it should be. Okay, so what's in the works right now? So we're not slowing down. We're now working on atomic swaps. It's a very important feature that allows actually people to exchange Beam to Bitcoin or Litecoin and later down the road other coins without any trusted third party, okay, without a counterparty risk. We have already demonstrated that, and we're now finalizing and ironing out all the bugs and all the error scenarios there. We'll be releasing it in several weeks. One-sided payments, it's a very important innovation in the Mimblewimble space. A little bit later I'll explain how Mimblewimble works, but one of the properties is that in Mimblewimble both wallets have to talk. So the confidentiality is achieved by the fact that there are no addresses and the wallets have to talk, meaning that two wallets have to be online, right? Not exactly in the same time, but during the same day, for instance. And it may pose an inconvenience, right? So it's not, with Bitcoin, I can post my address and fly to Mars and then come back in 10 years and have like all the money that people send to me. Not so in Mimblewimble before one-sided payments. So one-sided payments will allow people to post something like an address and receive funds to that address. So it's a very important feature. Lightning. There's a lot of talk, I'm attending the Magical Crypto Conference now with all the Bitcoin people. There's a lot of talk about Lightning. There is also a lot of skepticism, but looks like it's a very important second layer solution for fast transactions, and we're working on integrating it as well. We'll show a proof of concept demonstrating how it can work. Beam Anywhere is something experimental we just released, I think a week ago, as a demo. And what it allows you to do is pretty cool. You just connect your wallet, say, to Telegram, and then it allows people to just use a bot and send Beam coins to each other using Telegram and only having to confirm the transaction on the wallet, on the mobile wallet. So in Telegram, I just type something like send 10 Beam to this and this username, and I get a message on my phone, pops up. I click OK, and then the transaction occurs. And then it can be expanded to other messengers and web and all that. So lots of stuff in the works. So how we are achieving that? We're moving really fast. So unlike a lot of crypto projects, we are operating as a company. So we have a team of people who are getting paid and are working on the project literally 24/7. But of course, this is not the ideal way, especially in the crypto world, right? Right now, we're a centralized body that's vulnerable to maybe government attacks that in theory can become evil. As a CEO, I can suddenly decide to grab all the coins for myself or something like that. And we know that it's not a good long-term solution, so that's why we're setting up this foundation, which has coins allocated from the treasury unconditionally, okay? And those coins appear for every block, 5%, like for every block there is 100 coins, so 5 of those coins 4 of them go to the treasury. And every month they are released, so the Treasury will be actually able to use those funds to issue grants, to shape the roadmap, to pay developers all over the globe to contribute. It will be able to accept grant proposals and also issue bounties for whatever it thinks will be necessary. And we don't want to control the foundation. So probably one of the board members will be from the original team, maybe two, but in total it will be 5 to 7 people who will be actually not related to us as the founding team and will have a good name in the industry and respect. So that's the idea. And the goal is eventually that this becomes a community project. Okay, so that's been so far. So now I want to spend some time talking about Mimblewimble and explaining what's so interesting about that. Right, so Mimblewimble was published almost 3 years ago now, in August 2016 by an anonymous person in the best traditions of crypto, probably a huge Harry Potter fan. So Mimblewimble is a spell from Harry Potter that makes you silent. You cannot talk if I do a Mimblewimble with my wand on you. So it's based on three pillars: the UTXO model, confidential transactions, and cut-through. So first thing is that in Mimblewimble there is no such thing as an address. Although if you start using our wallets, there is a thing called address, but this is just an abstraction to start the conversation between the wallet. On blockchain there are no addresses at all. Instead, the blockchain looks exactly like, well, not exactly, but this is like a metaphor of how the blockchain looks. So there are a lot of safe deposit boxes, each of them holding value. Now users hold keys to those boxes, but all the boxes look exactly the same from the outside. So you cannot tell how much money is in each box, and you cannot tell who it belongs to. So only when the user actively comes and uses the key, and all the keys are different. So it's not the same key, so it's a different key for each box. They're all generated from the seed by using the pseudo-random generation. But an outsider cannot even see the connection between the 3 keys that Alice has here. So each of those boxes represents a UTXO, an unspent transaction output. Okay, so the UTXO is represented by this mathematical construct called the Pedersen commitment, where these are the generator points on the elliptic curve, huge numbers. This is the value, so if I have 100 beam, this will be 100. And this is my private key, or blighting factor. It's just another name, okay? So, and they, like from the outside, this P looks like a total garbage, right? You cannot figure out anything, okay, if you just see the value. Now, when I make a transaction, I take my UTXO. Let's say I had 80 coins in my UTXO, I just mined a block, and I want to send, and Alice wants to send 30 to Bob. So what she does, she starts talking to Bob. Bob creates a safe deposit box for himself for 30, and Alice creates a safe deposit box for 50, right? It's a change. So they do that, they sign, both of them sign the transaction using Schnorr signatures, and then they send it to the blockchain. And now, the blockchain needs to validate that the transaction is valid. So how do they do that? They don't see the actual values. The only 2 things they can validate is A, that the sum of inputs equals the sum of outputs, right? 80 is 30 and 50. And that all the values are positive. And for this, we're using zero-knowledge technology called bulletproofs. Why is that important? Because I could take 80, give this guy 80, and give Alice minus 160, right? The sum would still be 0, right? But then we would actually print money out of thin air. And this is not, not desirable. Okay, so some zero-knowledge proof validates that the sum is 0 and the values are positive. That's what we need to know about Mimblewimble. Okay, and we're done here, yeah. Just 1 second. Okay, so and now this is the situation. So now we complete the transaction. Now this new UTXO belongs to Bob. It's registered in the blockchain. validated, and now Bob has this new UTXO, and Alice has a smaller one as well. Again, nobody sees neither the sender, nor the recipient, nor the amounts. So fully confidential. And another very neat trick in Mimblewimble is called cut-through, and that's why the protocol is very scalable, and that's why the blockchain is small. It's 3 to 10 times smaller than Bitcoins per transaction. It's a very important property, right? Bitcoin's blockchain today is about 220 gigs. If you look at Monero is about 5 times fatter, and if it had the same usage, it would be a terabyte, which kind of rules out running a node even on this baby here, let alone a mobile phone, right? And if we reach the transaction, the scale that we want to reach, right, the scalability of blockchain is very important. And we're also working on additional techniques to make it even easier because, right, we want a situation where anyone could validate the blockchain, where you don't have to trust anyone. And if you need a supercomputer for that, it's a problem because you don't have a supercomputer, right? So what this transaction cut-through does, it just cuts through all the intermediate states. So if Alice sends this coin to Bob and then Bob sends the same coin to Carol, we don't care about the intermediary state. We don't store the intermediary states. We don't store the history. So eventually, all the blockchain can be represented as a huge transaction from all the mined coins, which are public, right? We know how many coins are mined. This information is public. So it's all like a huge transaction from all the mined coins to all the existing coins right now. And there is a proof that the transaction is valid. And that's it. And that's why the blockchain is much smaller, so no history stored. Okay? So what is next? So now we've built this confidential coin. We're building more stuff on top of it, but we want to make it into a larger ecosystem. So how are we doing that? So first thing to talk about is called confidential assets, right? So as you might remember, an asset is represented as this Pedersen commitment, which uses 2 generator points. But if we change one of them, then it becomes a new kind of asset. So very simple, we just change this H number, and it becomes another asset. Like we change to H tag, and it's a new asset, right? So that allows us actually to create tokens in the same fashion as you do on Ethereum or other platforms, maybe somewhat similar to colored coins concepts that were developed before. But the idea is that you can issue several kinds of assets, and we can create issuers that actually, assets can have their own emission schedule, they can have even some rules and a contract server that defines what's going on. So those assets can be dumb, meaning it's just a token which can be sent to anyone, and the transactions work exactly in the same confidential way as the Beam coins as well. Or they can be smart. Having a smart contract assigned to them. The platform itself does not support fully Turing-complete smart contracts. There is something called scriptless scripts that allows some primitives, and we can use external Oracle servers to do smarter things. Now, one example of that issuance of those confidential assets is a bridge. Okay, imagine a bridge to, say, Ethereum, where you have a regular Ethereum smart contract here that locks certain asset, let's say a DAI coin, right? Let's say the use case is I want to trade my DAI coins in full confidentiality, right? Because on Ethereum today, for those who tried it, you know, it's all like an open book. It's crazy. Everyone can see how many tokens you have of what kind, and when you send them, it's super easy and super scary. So I just put my DAI coins here. A B DAI is printed here on our side, and then you trade it confidentially as long as you want. Okay, but then at any moment you can cross the bridge back and get your DAI back if you need to. Okay, that actually gives you like maybe not a full confidentiality solution, because still on Ethereum it will be seen that you send some DAI to this contract, right? But whatever happens in our blockchain will be totally opaque and nobody will be able to see that. It can be very good for traders who suffer from front running, and just for anyone who wants to hide their transactions. Okay, another thing we're now looking at is just issuance of smart assets. For example, STOs. There's a lot of talk of STOs, also a lot of skepticism, but we're seeing this gaining some speed. So the issuer, it's the same situation, but just without the bridge, right? So the issuer creates a smart confidential asset, issues it on the blockchain, and defines the rules that are required. And the rules can be such that for each transaction with this asset, the issuer must issue approval. And that's how the STOs work, right? They issue shares, there are some rules that only people who meet certain criteria can buy those shares, and the total number of people can be this and this, not less, not more. So we're planning to enable that as well. And remember, I started with scalability, confidentiality, and compliance. So by compliance, we mean is a way for people to create a trail on the blockchain only if they choose to do that. And then to be able to present that trail to whoever they need to present it to, right? It can be a regulated exchange for AML, it can be an auditor for financial audit, it can be a tax person for taxes. But again, very important, it cannot be enforced on those who don't want to do that. And in my vision, businesses eventually will be using this opt-in compliance where private people will not. Because as a private person, I don't need to report my financial transactions to anyone, especially with just spending money that I receive, right? But again, it will of course depend on the country, on the regulation, and everybody will be able to decide. More or less same as with cash today, right? I can accept cash and not give you a receipt if we both agree, or, you know, as when I buy a coffee, usually I get a receipt from Starbucks even if I pay with cash. Okay, so the way it will work is that, remember, the same transaction, right? But there will be an option to attach data to this transaction. The data itself will be stored offline, but the transaction will have like a hash of that data referencing the offline documentation that will be stored forever on the blockchain. It can also store the history several hops back. But the point is that because, remember, the protocol is conversational, both sides need to talk to create the transaction. So they need to both agree that this history will be added. So one scenario is that Alice wants to pay Bob, but she demands that he attaches an invoice, okay? And then she can review the invoice and then store it or reference it from the blockchain. And then in the end of the day, or a year, it all can be shown to the guy here, to the auditor or a tax guy. So, and this is the opt-in compliance. Again, cannot be enforced backwards, strictly optional, geared towards businesses. We think this will actually come into play not tomorrow, but maybe in a couple of years from now, because today, as we all know, businesses are not really accepting crypto that much. And it's not just because of lack of confidentiality, but for a bunch of other reasons. But when this movement starts, we want to be there with a full solution. So, you know, in this talk, I wanted to show that we solve the trilemma of confidentiality, scalability, and compliance, and that when the barrier of acceptance, the barrier of adoption is broken, businesses will understand that they need all those qualities and that Beam is the project that is doing that. Today, we start hearing some talk about that, but there are some solutions who are trying to build privacy on top of existing protocols like Bitcoin and Ethereum. It is very hard, if at all possible. Now, the confidentiality projects like Monero and our friends at Grin and maybe a little bit less so with Zcash. Those guys have this cypherpunk mentality, and which we respect, but we're not exactly like that. And they don't believe in compliance in general, right? Because this dream that it will be a beautiful new world with crypto ruling, we don't believe that the banks are going to evaporate any time soon, and the governments are also not just putting their stuff down and going home. So we have this very realist view on things, and we want to build an ecosystem that allows people to transfer all kinds of assets, all kinds of value, with scalability, confidentiality, and compliance. Thank you. Any questions?
Hello. My name is Ben Noble. I've actually talked to you before, but I'm helping with the privacy summit with Grid and all that, and so I know compliance is like a huge flashpoint. The opt-in compliance, I get how that handles the enterprise side of the issue, but like for AML compliance and money laundering and tax evasion and things like that, do you see a way that that can be addressed with a privacy blockchain, or do you think that's like just a point of contention that's not going to be resolved?
I think it can definitely be addressed. So for AML, what's important for those who do AML checks is to see the provenance of the coin, right? So if I buy a coin on a regulated exchange, and then I send it to you, and then you send it to Alice, and then she comes to a regulated exchange, she wants to be able to demonstrate this path, right? Now let's imagine a situation where we have a set of players who agree from the get-go to play this compliance game. They all go through KYC. Okay, all their wallets are KYC'd. And then when they create a transaction with someone, they agree that the history is stored offline.
Right.
Okay?
So as long as people are acting within like the regulatory constructs,
Exactly.
in the same way like cash can be
Exactly like that. Because Starbucks, I mean, in theory, they could have not given you the receipt and just pocket the money, right, and not pay taxes, but they're not doing. I mean, some businesses are trying to do that, but they're getting caught, right? So we want everyone to have this choice, and we think that businesses will want to report, because you cannot run a business and not, at least in this country or in other countries where the financial surveillance is strong enough, or tax authorities are strong enough, and probably most of the good countries that we kind of like to be in. So the idea is, again, that people will agree to play this game, and for every transaction, they will agree that this is what's going to happen, that this encrypted history is stored somewhere.
Right. Yeah, I think the opt-in is a good idea.
Yeah, and I think it's super important, because obviously the government would want to know everything, right? And today with Bitcoin, they kind of do.
Yeah.
Or most of it, or it's arguable, but as time passes, they learn more and more and more. But I think our message is that it's, the confidential currency genie is out of the bottle. And there is no way you can, destroy it or forbid it unless you're trying to get to every person's, wallet, or it's not practical. I mean, you can maybe forbid it from exchanges, but that's it. Like Japanese government did, for different reasons altogether, by the way, and they might even re-enable that. So we want to build a system where people have their privacy, but they can comply if they want.
Thank you for your presentation. I've got two main questions about the presentation and Mimblewimble. The first one is that regarding to the bridge protocol, you were mentioning about maybe some Ethereum smart contract, DAI token, and you might be even able to trade some Ethereum-based ERC20 tokens through the Mimblewimble protocol. So in terms of trading, you guys would be those tokens would get some confidential, but do you see any possibility for non-UTXO model public blockchain cooperation with Mimblewimble or implementation?
Sorry, for some, what?
Non-UTXO based public blockchain cooperation or implementation.
Non-UTXO, like, for example, what?
Like Ethereum or whatever. Like, yeah, Ethereum would be one of the examples. Those blockchains who are not using UTXO model.
Well, I think as long as there is a smart contract capability or some capability of this network to lock assets and inform our network, then we don't care. It can be you know, a relational database. So I just like in this scenario, our issuer, where were we? Our issuer server will just receive a command. Oh, that was too far away. Will receive a command from someone trusted that it needs to issue a token, and what kind of token. So these are the rules. So the bridge actually defines that for anything locked in here, a representation or something is printed here, and then the other way around. For anything burned in here, something is released in here. Of course, it's very simplistic, but you get the basic idea. So then, as I understand, it doesn't really matter. This can be just a relational database or loyalty points or dollars, but of course for dollars you would need a bank here, right? So it's like a different story.
And in terms of Block Explorer of main project, what are some of those information or data that we would be able to search or check for?
So for some of those assets, you will be able to distinguish them. So actually, it's a little bit deeper in technology, but there will be two kinds of confidential assets. One kind that's freely issuable, you will be able to distinguish it on the blockchain. Again, not the sender, not the receiver, not the amounts, but you'll see that there is a transaction with that kind of asset. Others that are pre-baked, and we're still debating that. I'm not sure we will or won't have those, but we might pre-bake several assets into the blockchain in the next fork, and then they will not be distinguishable. So then you won't be able to see much on the blockchain explorer.
Last question.
Hello, I'm Denko. I have a two-part question. The first one is about the proof of work algo. Is it ASIC proof?
So the algorithm we're using right now is Acquihash with custom parameters. In its own, it's not ASIC proof, but we announced two hard forks. One is going to be somewhere July, August, and another one at the end of the year, where we'll change the algorithm. I cannot tell how exactly, but the purpose is that there are no ASICs in the first 18 months. But then we will not be doing any more forks. Now, the algorithm is memory intensive, so it's not very ASIC friendly.
Right now, right?
Yes, right now, and it will probably stay that way.
Okay, so it's then the second sub-question is like I've been following this project, and for some time we started like mining at the first day of mainnet launch, and based on the hash rate calculation, we figured that there were over 50,000 high performant GPUs comparable to 1060 NVIDIA or something. So it was not really profitable. So the question is, like all those GPUs that showed up, is there any association between those mining pools and the company itself in the background?
So I'll tell you a story. So on January 3, we were launching, right? It was a very, an amazing moment. We were sitting in the office in Tel Aviv. We were back then very high up in one of the tallest towers. So, and we had to set the difficulty, right? We had to set the difficulty to a certain number. And we thought, okay, so let's think how, and before that we were running a test net and we had maybe 10, 20 GPUs mining. So we said, well, you know what, let's set it to 10,000 GPUs because there's no chance there will be more than that. We were kind of thinking about there will be 3, maybe, we didn't know. So we set it to 10,000. And then as I said, it was 50 and then 100,000. So we were not associated with those people because as a company, if you want to do that, you need to buy power. Right? We did talk to some miners before and said, hey, we're launching, and but we couldn't pay them or make them do anything, right? So it was all organic. It was all organic, so people were prepared before. And also right now, we know the big mining pools, we even talk to them sometimes, but there is no financial or any business relationship. They're just doing their thing. Thank you. Thank you.